And we are getting started. Good morning, guys. Day 9. We had a successful training run last night. So today it's time to consolidate things a little bit, push out the changes. Let me just move this here. Let me share the stream with the people in the channel. Again, for those of you who haven't seen it yet, join the Discord server. You'll find the link in the video description, in the stream description, and in particular the open NLLB channel here. We have a ton of new people joining here. So do join yourself if you want to contribute. If this is something that's interesting to you, do join us. Okay? Having said that, let me open up the Notion. Let me wait for people to join a bit, and then let's go through the tasks for today. Let's see what else we've got to do here. Slurm. Okay, here's some tasks that we have to do. Let me remove this. These are some of the tasks we'll be focusing on today. I think we should start just computing the number of parameters with the current settings. I think it should be around 615 million, the model I trained last night. Well, let's double check that. And then we can maybe, it would be a good exercise to just enable Apex, just to estimate the time it takes to train the model. Roughly estimate last night was for 100,000 steps, we need around 16 hours on my system without Apex. So maybe with Apex we can get that lower somewhat. I have no idea of what the performance gain could be, but we can start there. So I think a reasonable order of operations would be push out the latest changes after we compute number of parameters, and then try Apex. If we get stuck too much, we don't have to dwell too much on it. And then I'd love to go through the whole pipeline again. And at the end, we're gonna compute the number of GPUs we'll need to actually train the system on a larger scale. So let's start here and then push out the latest changes. Refactor before that, of course. That's the plan for this stream. For those of you who just joined, good morning, guys. Good day, good evening, wherever you are. Let's start. Okay, fair sec. Let me open up the train script, which we kicked off last night. So that's under fair sec CLI, train.py. And let's see where the model is being built so we can grab it and compute the number of parameters. Call main, distributed main, which then calls main. Okay, let me see where we pass the actual main function here. And that's also, just a second, where is it actually stored? I guess here. Okay, here is the main function. Let's see where we build a model. I think it was somewhere below there where we wrap it up. So build the model is here. Okay, so let's see whether they have any count the number of parameters already functionality, or I have to think of a way of how we can do this. By the way, guys, let me know if the sound is all right, if everything is fine on that front. Count parameters. Analyze data, that's my function. I just see, okay, maybe something like count params. Or we can just write a simple function ourselves. Okay, I definitely don't see checkpoint utils. If anybody's familiar with fairsec, which I doubt, let me know if there is anything we can reuse here to just grab the, maybe we can go to the base class. Let's go to base class like transformer base, if something like that exists. Let's see. Searching for transformer base or just transformer, and then we can take it away from there. Transformer model. Let me see. Fairsec data class and then module. All of these are modules. Maybe this one. Transformer model. Transformer model base. Let's see whether there is any count operation here. Count. What's the API of this model? There is the build function, the add arguments, the build embeddings. Okay. Count number of parameters, PyTorch. Let me remind myself how to do something like this. So we just go through the model parameters and we see which ones require gradients, and then we just grab size products. Looks good. Okay, something like this. Looking good. That's the same solution pretty much. Let's go back to train. Let me quickly add this function here. And then let me see whether somebody is already doing something similar in the repo. That's how we can find the actual implementation. Taking this also just to get familiar with fairsec. Good opportunity to get some familiarity. For RAM, update, the type. Okay, it's mostly just to fetch the number of devices. Check before, after model size. Get model size. So there is the model size function somewhere here. Okay, here it is. Okay, fair enough. Let's see a couple more places here. Model parameters. This is just setting the gradients to true. Check sum. Basically just sums up this and uses that as a checksum. Interesting. Aha. Okay. Well, there is actually the number of parameters is being logged directly in the train script. So that's exactly what I was looking for. So yeah, turns out we don't need anything. We just need to run the script. Okay, let's run and hit this particular line. Hit run. Hey, welcome guys. I see MD sent okay. I'm not sure what's that referring to, or just a general statement, okay, which is also fine. Yes, in other part, we're gonna have every single day over the next days, and then I'll be going to Shanghai, so that might slow me down a bit for a week, but then we're gonna continue again full steam. Let's see. Number of elements. Get expert. Okay. Number of shared model parameters. Number of expert model parameters. Okay, it looks like we have 307 million parameters. Interesting. I would have expected more. Are we counting, are the embeddings being picked up here as well, or is this without embeddings? Let me quickly return back this function here, count parameters, and let's just call it as well and see whether there is any difference. Size, and then format, and then pass in this and pass in the model. Okay, looking good. Let's rerun and get back to here. I need to check the internal model dimension and see what's the size of it. Because I thought that 12-layer transformer decoder will here in Farsec by default be of 600 million. I might have been wrong. Model size, okay. 307 million parameters. Interesting. Can we somehow fetch the embedding layer? Let's see. Build the model. Let's go inside of here. Let's quickly just dig into the model. Let me stop this. By the way, FYI, for those of you who were not here last night, we managed to run the training. So everything is set up end to end. At this point, we won't have weights and biases set up. So now it's time to just polish stuff a bit, push out the changes, estimate the amount of compute costs, compute hours we'll need on, and how many GPUs to actually train the bigger checkpoints. Let's go build model. Let's enter here. Let's go all the way here, enter base architecture. Okay, build the model. Okay, the dimension is 1024. Build the embedding. Build the embedding. Dictionary. Let's just enter here quickly. Okay, wait. Okay, here we are. Constant. And then create the actual embedding. How can we get the size of this guy? Can we just do size? Or we can just compute directly 1024 number of embeddings and then just estimate the cost. Initialize with this, so number of embeddings times embedding dimension. That's the number of parameters here. And that's equal to what? $262 million. Okay. Yeah, we just so this already in and of itself, because it's such a big dictionary, it has like over 250,000 tokens. It's already super big itself, in and of itself. So then I'm surprised that the rest of the model is as small as they say it is. Let me see, are we sharing? I think we are. Use stable. Let's quickly see. Share, because we are sharing the embeddings, we'll just have a single table. And then the encoder, we can compute the size of the encoder here directly. Let me just see if we enter here. Transformer base. Okay. Might be easier to just go up. Go up. Hey Bubble, what's up, man? Thanks. Nice to seeing you again. We just had a call before the live stream, the two of us. Bubble works at Meta, doing amazing work there. Okay, encoder. Let's see what's the easiest way. You said try dictionary. Okay, let's see if there is anything interesting we can call. Training parameters. Maybe we can grab parameters, buffers, backward hooks, forward hooks, modules, embed tokens. Okay, let's just try and see what we get if we call parameters. It's an empty dictionary. Okay. And buffers. Interesting. One thing that we can quickly do here is modify this. I think that's going to be maybe the easiest way. Just pick up the function we built in the train script. Let's go back to the train script. Here's CLI, train script. Let's just grab this one. Let me literally paste it to where we now are located. I'm just gonna make it hacky like this. And then this should work, right? If we do print some parameters of encoder and then do the same thing for decoder. And let's disable all breakpoints except for this one. Stop the run. And re-trigger the run. We should be there quickly. Just want to make sure we are not because there's this wrapper around the model, maybe something is getting messed up. I did expect more parameters, and line 124 print for decoder. Oh fuck, yes. Well, we'll be able to call it in the debug console. That's also fine. Okay. Okay, so here we see 413 million. Interesting. And then that means once we build decoder, let me just call this directly from here. Hopefully it's gonna be defined. Let's see. Okay, name decoder is not defined actually. Maybe I have to, okay, now it will be. So let's rerun. Okay, same number, right? We get the same number for decoder and encoder, roughly. So this gives us quite a lot more parameters than plus the share embeddings. It looks like billion. So what's the difference? Why do we see only 300 million on the top level, whereas here we see much more? What's the thing there? Again, this looks like 400 million here, so that's almost 900 million plus we saw that for the embedding we have around 200 million, so that's over a billion parameters. And then we retrieve that back. We initialize. We literally just add those here, and then we check for types. And then we just add something more. So nothing changes there, right? So after this is done, maybe we can add, let's quickly add, I mean, this is fairly hacky, but we're in the business of hacking today, so quickly add this here. Will it actually work if I just call, what's the chance of the, yeah, the scope is different, so that was hopeless. Okay. Looking good. Let's add a call there. Disable all breakpoints except for that one. Retrigger. Let me just stop this run, stop it, and rerun. Thanks a lot, Martin, for catching the bug. Although, as you saw, the function was defined in that scope, so we could just call the debug console with the right parameter decoder instead of encoder. Okay. So guys, literally 615 million here, which is the number that we expected, right? So this is indeed the model that so now the part that I'm confused about is maybe after quantization or something, we get a smaller number of parameters. Well, that doesn't make any sense. We're not doing pruning, right? We're just, this is the number of parameters, not the number, not the actual size. That depends whether we're using half or float 32 or whatnot. Thank you. Okay. So what's up? Why? Anybody has an idea why we're getting these discrepancies? It's literally the more we go, the higher up we go, the less parameters are surfaced. maybe weird. Let's enter here. Okay, nothing happens there. That's just a no op. And then we come up there. We wrap up the model. And then once we come here, and once we print here, we get half the size. Okay, guys, it's half the size because we are sharding the model. I assume in the background it sharded the model across 2 GPUs, right? So that's 307. That's the fully sharded wrapper. So it's like literally if we time 2, we get 615, which is precisely the number we were looking for. So that's all good, but I'm still confused why when we computed the number of parameters in decoder and encoder, that was higher than right now. What are some of non-trainable parameters that are not being considered? It's a bit of a mystery. If anybody has a clue, but until then it looks like on the high level here we do have what we expected, and that's 615. Okay, now let me clean up a bit of this mess I made here. Okay. Is it not mentioned in the paper? It's not. For this smaller one, they don't even train. They distill 6 to 615 million. They never train directly. They just do distillation. Let me clean this up. And let me clean this up. Weird. We get encoder, we get decoder. Why would this be different in size compared to the when we are up in the top level of the code? Okay, it might be the case that we are double counting the embeddings. Maybe the encoder and decoder include the embedding layer. Let me just double check that hypothesis quickly. Let's rerun. Let's rerun it. Hit F5. Here we are. Okay, we built the embedding. Here's the embedding. Okay, it's literally returning torch embedding. go here. Let's exit. And then we just return back that embedding here. Share decoder input output embed true. And then we build the decoder and we pass in that same embedding. Where did we set the decoder? Okay, we just made it a reference here. Okay, and so now that we enter here, let's enter here, build decoder, embed tokens. Yes, I think that's the case, guys. So because of the dimension of this one, this is 256,206, 256,206 times 1024, oops, 1024, we get 262 million, and this is being triple counted. Or double counted, sorry. So embed tokens is being saved here, but later we tell it, hey, this is shared. This is actually shared. But once we go outside here, and again, this encoder now counts in, it has the embedding table, and decoder will also have the embedding table. And that's why we got those big numbers before. It was 400 million something, 400 million something. If we subtract from that one embedding size, so 260, we literally end up with 650 million. So all is good. Everything makes sense now. Okay, we can stop this. We got our solution. Let me just quickly confirm. Okay. Looking good. Let's push out the changes we made. Versec. Let me navigate to the root here. Let's see the changes we made. Analyze data. Let's start from bottom up here because it's easier. Okay, Versec CLI, what did I change here? I think it's just, okay. Aha, this is a new one. I just made this one to explain how to run weights and biases. Okay. Looking good. I think we can check in that one. Parse temporary, I'm gonna delete that one likely. So let's go to NLLB, modeling, parse temporary. We can delete this one. Let's continue. Dataset, zip. Okay, this is just data, so we are done there. Let's see what else we have here. So train script, what did I change in the train script? Let me see the diff. I added random. And I made a couple of hacks here. Okay, this is not something we want to check in. If we pass the same name here, what will happen? Will weights and biases be smart enough to change the run name if we pass in the same one? I think we can leave this as it is. And then we don't need a random. And so now the question is how to fix this. Let's see how we can disable validation directly through command line as opposed to hacking it in the code directly. Disable validation, where is it specified? Okay. I think we can just specify it as a flag here. Let me just see one more thing. Is this one mentioned anywhere? Configs, dataset config. Okay, disable validation. Let's go and set it up here. Disable validation. Double dash. Let's go to train. Disable validation. This should already be equal to true. Let's just double check that. Disabling all of the other flags. Okay, here we are. Okay, it is set to true. So we definitely don't need this. And then how do we set the validation subset such that we are not entering this other branch? Let me stop this run. Okay. This is the only change I have in the file. So let me uncomment this quickly. Let me remove the pass. And let's enter here and see what happens if we just set valid subset to empty. Let me rerun this. Okay. So we end up with empty, and then when we enter here, the split is empty. Why then? Okay, estimate the shard epoch. None. And we attempt to load. So then it's gonna fail definitely, because there is no protection against invalid strings like this one. Split. Yeah, this is just gonna fail. So let me stop this. Let's go back to the train script. Okay. What can we do here? I mean, we can always pass in. Okay. Let's just pass in one of the shards from the train dataset just to make the error go away. Let me see how we can do that. Train.py valid. I think one quick solution is if this disable validation is enabled, we should not load the dataset, right? I think that's a reasonable fix. If config dataset disable validation. If it's not disabled, then we go and run this. And then we can remove this. And now we're good. So if we have disabled, then we will not be loading the datasets because we will not be validating. So I think that's a reasonable fix. Again, just added a if not disabled, then load. Otherwise, don't load. I think that's the reasonable logic here. We are skipping. We are literally skipping. With this disable validation, we are skipping. But it was complaining for some reason still. because they forgot to add this guard I just added myself. So here we'll just now be skipping, and then if we kick off the run and here as well, nothing will fail. At least that was the case last night. So this is a reasonable fix. I think we can check this in. Git add train. Oops. Let me stop the run because otherwise it's going to be very slow. Okay, here's the project. Let me just quickly see whether the name of the run makes sense. Okay, the name of the run is save directory. Let me see if I kick it off again, whether weights and biases will handle it gracefully. I'm gonna stop this again. I know that my stream is, by the way, getting laggy after I start running this, just because I'm almost using all my GPU capacity, so the video encoder is struggling when I'm running this in parallel to streaming. I don't have that powerful machine yet, but soon enough. Okay. See? Just curious to see how weights and biases will handle this. So currently we have these two. Because this is the name of my directory, so it's not really an interesting name. Okay, it literally has the same name. So I'm not sure whether that's gonna cause any issues if we have same name runs. Well, the color is different, so okay. Let me stop this. Stop the run. And let's go back to submitting the code. Okay, analyze the data. Bunch of YAML files followed by README. Let me see what I changed in the README. Let me do git diff tool. What did I change in the README file? Okay. Dataset utils. I copy pasted this whole logic from the filtering stage. Okay, this is kind of confused. The smell tool is confused because the files are of different lengths. But okay, I know what's the difference. And we can also check it in VS Code directly. Let's go and find those scripts. Okay, here we are, modeling, data, dataset utils. Here's the difference. Let me just add a comment here that all of this is copy pasted from below code is copy pasted from the filtering pipeline of Stokes repo. Okay. Collections. Okay, looking good. We can submit that file. I did modify some defaults here in the dataset line, so that's a bit different compared to the original code, but that's it. Okay, let's submit the file. Let me git edit. And finally, analyze data. That's kind of a mess. I added a lot of new functionality. Let me see whether I can quickly clean it to push out this code. What do we care about? If dedupe, then okay, we can import and create like a enum class. We just see the syntax in case they already used it somewhere. Oh, this is mostly here. Okay, just copy paste that. Feature type. We're gonna have dedupe. We're gonna have line lengths. We're gonna have the third one was number of sentences. Okay, and then features is gonna be a list of feature types. Okay. So if this is in features, then just a minor refactor here. Okay, line lengths. In that case, we don't want to length factor. And threshold. Let me quickly refactor this. So we here want to pass that as length vectors path. Not required. Path to the length vectors file. Created in the Stopes repo. And then I'm gonna set this to in my lone JSON for the analyze data script. Okay. Looking good there. And then line threshold. This one is just going to be a constant. Up the line threshold. Okay, sounds good. So here we load the length vectors, that's good. And then we go through the directory, we grab all of the files. If the length is 0, we continue, otherwise we expect byte text. So this is validated if we pass in the filtered, path, filter data, that one might have multiple gzip files, more than 2 in the directory. So because of that, this assumption here is violated. And ideally, I'd love to be able to process both with this. So I'm going to remove this. And even we don't need even this then, because it's going to be adding 0, so that's all fine. So number of files we found is this many. Sounds good. Count the number of lines for each file. Okay, let's see, what do we do here? And this is just some plotting, analyzing dumps. Let's go and fix this file here, this function. Line lengths, count pairs, duplicate count. So again, we iterate through this script. Again, this is violated. So I will have to convert this back to for loop. This has to be a for loop. So we grab the files. we have to go and do for lang code for file lang code in this. All of this needs to be there under the for loop body. And then to get the actual language code, we will have to convert it using this mapping. So language code is this, because we're always dealing with BCP47, which is just a 3-letter code followed by the script. So let me remove all of that, and then let's create the file path. Same as here, file path. And then that means we don't need this. Okay. So now there is a couple of branches here. There is this one, the line length. There is the dedupe. And then at the end, we do something. Let me just add feature dedupe because we're using an enum now, not the string. So if this is in features, we print found that many duplicates for the languages. Remove this. Number of sentences. Sorry, a little digressing question. Akash asked, just curious to know what's your daily schedule now? How do you stay organized? What when you code, and how do you stay updated? Oh, that's a long topic, but now I'm just streaming for 10-11 hours while doing this, so that's how I stay organized. I start around 10:30, 10:50 a.m. CET time, and then I do 3-hour stream, then a short break, then 3 more hours, then a bit of a break for workout, and then I stream again for 3 hours. So that's roughly 9 to 10 hours. I'm aiming at 10 hours roughly. And then in the evening I check sometimes AI news, but that's more on a weekly schedule rather than a daily schedule. So it depends, but that's kind of the basic structure. A couple of breaks and a ton of work. Okay, if number of sentences is in feature, then we say the following: counting lines. Okay, so now what's the issue? What happens if we have 4 gzip files? I want to pair them. I need to pair them so that we can count up the, especially for deduplication. That was the reason why I had to do it like before without the for loop, because I'll have to have pairs of sentences somehow and not file by file. We can't do deduplication if we're iterating like this. That's the reason I had to implement it like the previous implementation. So let me think, how can we go about this? Because I want to make this agnostic, whether we are dealing with raw data or filter data, we want to have the same code path. Let me think. We need to find the translations here. Let's go to Stopes quickly. And let's see the structure of the output of the filter data. Filter out, here it is. So sometimes, as you can see here, we can have files and we have no idea. No, but they're, yeah, okay. They're all from the same. They are all from the same language direction. That's a good thing. Just potentially from different corpuses. And we know the exact format. The format is dataset name, followed by direction, followed by gzip. So let me think. We need to fetch them 2 at a time as opposed to going 1 at a time. That's what I'm trying to do. Okay, maybe we can do it like this. Because we know they're always going to come in pairs. We can make that assumption here. And so once we retrieve this, instead of going like this, let's assert. We need to assert that the length is we have a pair, either 2, 4, or more. Expected and even number of files. Okay. And now we want to go like this. For I in range zero to length with a step of 2. We grab the now we grab the data. So we do it like this, and then like this, and then we map like this, and then we map like this as well, and then we construct the file path, and again. Okay, that's looking better. So now this should work. Count number of pairs. We count the lines in one file and the other one, and we store that for their language codes. Okay, that makes sense. This should work. This one looks good. Let's go the line lengths branch now. Line lengths branch is here. So let me think. So there is additional condition. In order to compute, we want to have a guardian here. So the language code has to be supported in the lengths. So if we don't pass the, for example, if this is Spanish and we don't pass Spanish here, we don't want to run this code. Otherwise, we run it. We grab the length factor. We open the file. We go through the lines. We compute the lengths. We append the lengths. if it's above the threshold and we are in verbose mode, if we are in the verbose mode, then we can print additionally the outliers. Okay, that looks reasonable. And then we keep on collecting the lengths. And we do the same logic here, absolutely. Completely the same logic. Which means, ideally, let's just refactor this code so as to reduce stupid errors. Get line lengths. Yeah, unfortunately a ton of arguments that have to be passed, so that's why I didn't want to do it. Quickly, let me think here. Just to reduce some of these. So let's pass in the code, the file path, the length factors, this guy, and verbose. I think it will be worth it. Okay, and then we can reuse the same code here. Now the name is a bit misleading because we can just name it populate because we're just adding here okay. And finally, deduplication. If this is in features, we go, okay, so if both of these, no, if any one of these is in the target language, then we do the duplication. So we open the files and then we go line by line, we create the dataset line and then we filter it. If it's filtered out, we continue, otherwise we increment +1. And then at the end, the duplicates count is just add it here. Let me see whether this will make sense, because we need to have a fresh, okay, for each language direction and corpus, we want to have a fresh dataset count and a fresh filter, because it's stateful. Internally, it holds a set to help us understand which are duplicate lines using hash computations. Okay, and then once we are done with that, we just add this. Okay, this should work, guys. This should totally work. We just need to guard this with this. We found that many sentences. And we can, oops, we can also store them. And then some plotting. Histograms, let me see what are we doing here. So we go through the languages. Okay, I'll be using this code quite a lot, so that's why I'm trying to make it of decent quality. So we grab the line length. Okay, that means directly that we want to guard this with the line lengths guard. So only if we have line lengths, we compute this. Hey Ashish, we're just refactoring some visualization code. I'm gonna run it in a second to show you what exactly it does. But for now, visualizing stuff, refactoring stuff, sorry. Okay, so we print some stuff here, like the max. Like the average. Line length, and then we print something like this, which means we can just put this up here and compute this up there. No worries. Okay, and then we find the outliers, which are the, let me just add the lower line threshold that was set to 5 in our pipeline. So let's here add the lower and the upper. So if it's either larger than the threshold or below the lower threshold, then we sum those outliers and then we see what's the relative, how many of those outliers we have compared to the number of lines. And then we print the number of outliers. Found that many outliers in the language. Sentence length outliers. And then we compute the histogram with line lengths. And we plot it. Okay, looking good. Let's just handle this. We already do this, right? Oh no, that's for the direction. This is a computation for, so up there we have compute the number of lines for a language. Up here we have, down here we have computation for a particular direction, right? Let me just solve this. Grab the files, count the number of lines. If it's different, something's not all right. Otherwise, we get the key and we just pass in the number of lines for this direction. I think we can just compute this directly up there, right? We can directly compute this up there. Number of sentences. Something like that. Making the assumption that language code 1 is always okay. We're gonna test that assumption, but that's it. That's the gist of the logic. We can delete all of this, and then we can put this print statement here. And delete the rest. Clean this up a bit. And then here we can plot we grab the values for directions and for number of sentences. Okay. we do the following. We grab the values, we convert into log values, and we print the keys. Okay. So what this does is shows us languages on the x-axis or language directions, and on the y-axis shows us the number of sentences for that language or for that language direction. That's it, guys. This is looking good now. Much cleaner than when we started. And analyze the dumps. This one is if we want to first run the pipeline with raw text and filter text, and we want to compare and see what's the difference after and before and after filtering. That's why I made this one. Number of sentences. We pickle this and then we open it up here. In order not to over-engineer this, I'm just gonna say run okay. That's good enough. Let's start. Let's test this for Spanish. This is set, this is set. I didn't set this one. Okay, let's go to long JSON. Analyze data. Let's focus first on the raw text. This is the raw data. It's not zipped. And this is the length, these are the length factors. Okay. Let's go back to the script. Analyze data. And let's run this. Hit F5. Hopefully no errors. Okay, of course there are errors. I missed something. Probably some of the arguments is required and we're not passing it. Let's see the required ones. Dataset root is required. Extended length path. Should this be required? Where do we use this? I don't think we ever use it. Okay. Let's rerun. Okay, again, some error. What's going on? We have, let me open the JSON on the right here. Analyze data. Dataset root. We pass that one in. Verbose. Okay, we are passing in this one, even though it does not exist. That was the thing. Length factors. I think now we should be good. Let's rerun. F5. No, man, what's up? I hate these error messages here, by the way. They're completely zero information. Let me see. Datasets root. We did pass that one. Oh. It says dataset. No, wait. Datasets root. Here it is. I did pass it. Why are you complaining? Oh, okay. Because we are running with wrong config. Makes sense. That was a silly mistake. Let's continue. I picked the wrong JSON config. Let's enter here. And let's see. So we are computing first the number of files. So we found 722 files that basically have the right suffix, meaning they are either source or target corpus. Quickly, let me just double check this one. Huh. Really, we should be just using the PCP mapping. Okay. This should be good, I think. Let's continue. So 722 files. Now we go here. We grab the files. And we'll be running this here. So let's collect the data and let's end up here. Okay, looking good. Counting files. All of that is looking good. So let's see what's the output here. Found 94 languages out of 202 languages. Okay. Found almost 300 million sentences. $211 language directions. And then we dumped it. And finally, we can make some plots. So this particular one is for language. For different languages, what's the amount of data? Log scale on the y-axis. So we can see that Russian is fairly present. English, of course. And then, surprisingly, a lot of Turkish. Turkish, Russian, and English are for some reason the most present data sets here. Russian makes sense, English makes sense, but Turkish, I didn't know there is that many people speaking Turkish. Maybe 60 million. How big is Turkey? What's the population of Turkey? Turkey population, wow, 84 million. That's big. Okay, and here we can see, again, not that clear because there is a ton of directions, but we can see some directions that are, okay, this is more like a qualitative thing. So these are the same because they come from a single, all of these directions come from probably from just a single data set. That's why we have this like a flat line here, if you're curious. Okay. Let me see whether, I'm just thinking whether this 211 language directions, let me just note that somewhere so we can keep a track of that. So we have in the primary data set, we have (94) languages. 279, 601, 702 sentences, 211 language directions. Okay, of course I did miss out, I didn't download all of the data sets, like, let me see, do we have, let me open up Stopes. No, there is actually data readme. Here it is. I'm not sure where we have these ones. Evi Eng, Lorelei, and Chichewa. I think we might have Evi Eng, but not the other two. So let's just confirm that. Evi. Do we have Evi Eng anywhere? Evi Eng. It's in the data, but I've never used it, or did I? Iwi. Those are just the files. Okay. So we've never actually used that particular data set. Okay. Let's now run everything else. Let's run dedupe, and let's run line lengths. All that for Spanish. Let's go. Hit F5. Hit F5 again here. Okay, so we can ignore this part. We've done that. Let's just see whether this works, whether maybe I messed up something. Hit F5, compute line length. So this is empty now, but if we just, okay, we're not, let me just put a breakpoint here. Okay, compute lengths, this is empty, but once we skip over it, then, okay, we add the actual numbers. Looks good. Okay. Okay, we can just now remove all of these and get to the very end. Let's see what's the output here. With length in there above the threshold, found 2 duplicates. Okay, just the output because we're running on verbose mode. So number of duplicates, 30,496. Again, these are some same numbers as before. Let me note it down again. Spanish. Apparently we have 30,496 duplicates. We have let's see how many languages we have in Spanish. For Spanish, we have 84,502. And then let's see the outliers. $1,040 outliers. Okay. And that's it. So we can stop this. And now let's run the same thing just for the filter data. Let's go to the long JSON. Let's put filter data here. Copy this. Put in the filter data. Put in this. And then everything else can remain the same. Okay. Let's go back. And let's recompute everything. Hitting run. Okay, some error in compute line lengths. Huh. Okay. This should work. And apparently one would expect that that's a default, but okay. Let's rerun. Again, same issue here. What's going on? Read the file and then go through the lines. Why are you complaining? We get an error. Can't decode the byte in position invalid start byte. Okay. Why is that going on? let's put a breakpoint here. Language code. File. Oh, because it's gzip. Okay. So we are opening up that file, even though it's a gzip file. Where else are we gonna hit the issues? Here, I guess. We can unpack it obviously and then read it, but let me see whether we can somehow decode it and just okay. Let's quickly try and just put gzip here. Let's see whether this will work now. Okay, I can't put encoding there. Rerun. Let's convert that into, let's decode. And let's see the length of that. 60, and then times the length factor. Okay, I was just wondering whether it will have any issues with binary, but it does not. So what did we change? We went from open to gzip open. That's the only difference. So can we just create a conditional there? So if it's a gzip, then we use gzip open, otherwise we use regular open. Python with context manager with a conditional. Okay. So we can literally just do a conditional one. Okay. And of course here, let's just remove these suffixes. Okay, looking good. So if it's gzip, just read it like this. Otherwise, just read it like this. That's sorted out. Now for dedupe, we gotta do the same thing, I assume. This might become a bit more cumbersome to read. Okay, we can break the line at least here, I guess. Or we cannot. We don't need the encoding part. Can make it a bit shorter. Okay. So if it's gzip, we open the file 2 with gzip. Otherwise, we open the file 2 with this fng. Looking good. Let's now rerun this. Okay. Yeah. Obviously, we have to additionally, because we're reading byte sentences before we put them in here. If gzip line 1 convert from exactly rerun. Let's see. Seems to be a bit slower, but it's working. Skipping a ton of files, some YAML files. Looking good. Let's see if this works nicely. One-third of the way there. While we're waiting for that, let me just see a couple of things we have to do. So let's push out these changes, and then let's try and install Apex. Let's see what's the deal with Apex. Apex helps us. That's an NVIDIA library that helps us use fused kernels, GPU functions, also known as kernels. Okay, here we are. We found 0 duplicates for Spanish, which makes complete sense because previously we filtered out all of the duplicates in the filtering stage. I mean, because we are running filtering stage here, right? So this is the data after the filtering stage, and hence we have 0 duplicates, and we would expect 0 outliers as well. 94 languages. This looks similar to our the statistics we had before. Would be fun to compare. Okay, line lengths. Let's hit F5. Found 12 outliers. How come? How come these were not filtered out? One would expect exactly 0 because we're running on, they're all close to 1050, but not quite. Interesting. Huh. Something's wrong with the filtering stage for sure. Okay. And let's see what's the number of sentences in Spanish. Let's grab this one and see Spanish, Latin, 52,163. So let me move this here. And then we have 12 outliers here. Do these numbers make sense? Let's do some quick calculation. We can do it here. $84,502 minus the duplicates minus the outliers, we get 52,966. Whereas after filtering, we ended up with these many sentences. So something happened during the filtering stage that makes these numbers not add up completely. I'd love to rerun and see whether we get anything different. Okay, but the good thing is this code works. So let's just first submit this code. We can stop this. Let's add the analyze data script. Let me see whether we have any mention of it in the README. To go to place for data analysis. Okay, let's add that. And we just have YAML files here. Data, that's all good. Okay. So what would we, a couple of files, data set analysis, readme and train. We fixed a couple of, we fixed the bug with validation data set there. Okay. Correction, and finally let me quickly find that repo. Okay. That's it. Let's go to Stopes quickly. Let's open up Stopes and let's see what's the situation there. Copy a path. Let's change the path to go to Stopes. Status. Prepare configs file. Let's see what this one is. Otherwise, bunch of, okay. Let's start with prepare configs file. In the, just a second. Prepare data directory, prepare configs. Here it is. Okay, at this moment we are only saving train corpora, supported codes, YAML. Let's refactor this so that people can actually use this. Let me see what's the best thing to do here. Yeah, okay, let's make this a decent file. Okay. Let me just add the arc parse. Same logic as what we've done in the analyze data here. Let me just copy this quickly. Copy it here. Import arc parse. What we need is the filter data root path. This is required. And then we need the train primary config path. Train primary config path. Both are required. Root directory to output directory of the filtering pipeline where you stored your filtered data. Path to train YAML, train primary YAML config. Which is the file that was created using let's see, where is the filter? Where is this? Okay, filter configs. To run those, you have to run where are those two scripts that we use to construct train primary and length vectors? Exactly. Copy path. Okay. That's it. Now prepare configs. Okay, looking good. Launch JSON. Let's just copy one of these. Prepare extra configs. I'm gonna call it like that. And then in launch JSON, let me just copy these two. Launch JSON. Paste these two. And then grab the actual keys. Filter data root. like this, and then the actual path, and then we need the last missing puzzle is train primary config path. Save that one to long.json as well, comma, followed by the key, followed by this. Okay. Prepare extra config. We get this and this, and those can be now passed in here as arguments. And let's just extract this. Go to prepare configs. Quickly extract this from the arguments. Args exactly. Args exactly. Okay. Config path. Looking good. So what we do is we go through the filter data. We go through the files. Language suffix, gz suffix. If the language, if it's a valid file, we grab the corpus name, we grab the direction name, we grab the source and target, assert that they are in supported, and then if source in the file, then we add that to this direction, this corpus, this source. Okay, so we create a mapping. Step 1, create a mapping between what? Language direction to filter data path. And then step 2, modify the raw text data paths. Map the raw text data paths to filtered data paths. Okay, so we load it, we go through its directions, some assertions, we grab the actual data set, we delete some keys, and we map it here, and then we save that to here, train corpora YAML. Okay, this is as clean as it gets. So let's add that file. Whoops. What else? YAML, we can ignore all of this. Now there's a couple of py files here which we need to see what they're doing. Okay, let's start with filter.py. What did I change there? Filter.py, let's see, what did I change? I added copy, and I added this logic here. So I'm afraid this is an optimization for running on a local system, so maybe we can make that clear. if you want to run this locally, then you want to run it like this. Otherwise it doesn't make sense. Because we ultimately want to run this on Slurm, on much more powerful systems. So because of that, let me see how I want to handle this. Before this, it was just group name. And just get the config and run the filter group. Okay, let's see. First of all, let's retrieve back these arguments. Remove this. Batch size can be whatever the number of processes on your system is, but are we running locally or are we running? Let's see what's the example YAML. Okay, and then just a ton of filters, directions, train primary, executor. So if the cluster is local, if we're running this, if executor cluster is local, then we want to run like this. So let's go back to filter. Let me just kick off this run with filtering configs. Okay, so config executor cluster is local and Slurm partition is none. Okay. Local. Where do we set the Slurm partition? Base config, I guess, and then executor. Where is the config? Filter config, executor config, Slurm partition. Set to none here. Let's go back here. So if config executor Slurm is none, in that case we run this, otherwise we run the old code. And the old code was this thing here. Right? The old code was just this. Okay, let me just close this down, delete the past part, and just copy this, go back here. Okay, this is looking better. Let me stop the run. Again, quickly do a diff here. Copy. So what I've done is basically if this is none else for group name, run everything the same. So if I am to remove this and do it like this, then it's literally the same code. Okay. Close it down. Otherwise, the number of processes overwhelms machine and leads to crashes. Over. We have to batch. Otherwise, the number of processes overwhelms the machine and leads to crashes. Slur station. Okay. Fair enough. So let's see. Number of cores on your CPU. And then we go for direction at one direction at a time. We create a directory and then we just pass in those directions. Modified config. Okay. This is good. Let's add this file. Let me add the filter pie. Let me see what prepare data readme. What did I do there? Prepare data readme. Okay, I did add some notes. Make sure to rename once you download it. There is a hard expectation on how it should be named. Otherwise, you'll hit some bugs. Fair enough. That's a good note. Let's add the readme. Let's go to binarize py. What did I do there? Okay, again, chunking. We need to do this if we're running locally, otherwise we do not need to do this. So let's quickly do this. Same type of tweaks are necessary here as for the filter function. So we have to batch, but we only want to do that if and only if we're running locally. Otherwise, we don't want to do this. So how can we double check that? I guess launcher contains the information. Yes, launcher should contain that information. Let's just rerun the data, or let's see, launcher. partition. If launcher.partition is none, then we basically run this code. Again, go to prepare data, go to binarize. If launcher if launcher partition is none, then we do this. Otherwise, we copy the old code. Let's kick it off. Disable everything except for binarize. Set this to no args config and run. Let's see what happens. Again, we are now running through the validation component of the pipeline. Removing cache, why? Why would you remove cache? Huh. Interesting. Let's see. Did they ever change the prepare data YAML? I don't think I did. Train corpora did not change. Output directory did not change. I never changed this. So what happened? Okay. Maybe we can just go here and see whether launcher, self launcher. We don't even need to go beyond here actually. Let me just stop this and rerun. I just need to check that the launcher is partition is actually none. Launcher partition is none. True. Okay, fair enough. So go to binarize. Go to binarize and just copy the old code, which looked like this. And that's it. We just put it here. We keep the names the same here. Or we don't. Just a second. Exactly. Okay. And then everything else should remain the same. So list here should not be list, and source list should not be this. So this is not looking good. Okay, let's see the changes. We can stop the run. Let's see the change. The only change is we add local run to actually run this locally. Because I don't think, I suspect many of them never ran this locally, the way I'm running it. And then to do, adjust this based on the number of cores on your CPU. Leaving it hard coded for now. Okay. That's good. I know this works. We already tested this. Add binarize file. Okay. You see this? Turkey mentioned. Sorry, Ulku? I'm not sure what you're referring to. Dedupe sharding. Let's see. Prepare data, dedupe sharding. What did I do there? I left a couple of to-dos. And added some expectations. Looking good. That actually makes sense. Let's add that file. Prepare data. Retrieve data and validate. Let's go with validate first. What did I change there? Number of tasks, looking good. Retrieve data, I guess the same thing. Yes. And then, so I can add those two and then prepare data. Okay, I did some modification there. So we are grabbing the, let's go there. So we are grabbing the path. We open it up, we load the train corpora, and then we pass it in here. Okay, that is good. Let's close this up. Let's add validate. Let's add everything that has spy. Can I just do it like that? Git status. No, let's not do that. Maybe I'm gonna include something that's not desired. So validate, retrieve, prepare, and we are done. Nothing else left to submit. So we made filtering run locally, binarization also by adding the batching, some readme stuff. Add a config. Okay. Add batch support for local runs. Okay. Looking good. Okay, guys, that's it. Okay. Let's now start doing some real work, quote unquote real work. We are done with this. Let's try and enable Apex and then kick off a run and see how much of a speed up we get. That's one thing. And then we can focus on making sure we are not making any silly mistakes throughout the pipeline, from the download all the way to actually, let me just add a to do. Modify the download datasets functions such that they take care of the structure as opposed to having to run the structure modification script later on. That's going to save us a lot of pain. So we're going to set an expectation that somebody who is building a download function, if we later include new datasets, that they have obligation to conform to a certain output structure. I think that's the idea there. Let's go and enable Apex. Okay, so for Apex, window here. So for Apex, let's read through the installation instructions. NLLB, installation guide, install Apex. So I think I've done this, but it did not work. So if we go here, if I list, we can see there is Apex as the first one. So I've done that. But then when we go to Apex, change to Apex, and then check out this particular commit E2O83DF, and then we run pip install. This fails. No cache directory, global option, CPP extension, global option, CUDA extension, global option, deprecated fused atom, X entropy, fast. Okay. Why is that failing? Let me remind myself. Failed building Apex. Let's see why is that happening? Python 3.9. Processing running, torch version, building, error from the sub process, failed to build for Apex because did not run successfully. Why? Failed cleaning build directory for Apex. Let's see whether anybody else had the same issue, but first, setup.py. Python binaries were compiled with CUDA 11.3. Okay. So when we installed PyTorch, we installed with CUDA 11.3. And what is Apex expecting? Let me see. In Apex setup py, in the check CUDA torch binary versus bare metal. Okay, let's go to Apex quickly. Let's quickly open up Apex file, open folder, open, go to Apex, go to setup. There is a ton of stuff going on here. Okay. So let's see where the line was in. Line 102 here. And also line 171. Torch util CPP extension CUDA home. Let's set the Python interpreter to NLLB. Let's run this file directly. Okay. Let's see. What do we get? If it's available. Okay. So torch version is this one. Major 1, minor 10. If the argument is CPP extension, yeah, we definitely want to. Is there no cache directory here? No cache. Okay, CPP extension. Let's just set some arguments. CPP extension, CUDA extension, deprecated fused atom, X entropy, fast multi-head attention. Okay, that looks like that's all. And then install it there. Okay, this looks good. let's rerun. This should now work. Okay. Looking good. Looking good. Version. We're just adding a couple of these versions. Okay, remove this. Okay, here is where we are failing, so let's understand why. It's a meme. Oh, sorry, I didn't see the Ulko. I didn't see your comment. I am not familiar with the meme. Turkey mentioned. What's the thing there? Turkey mentioned. You're a Turkish, I guess. Send me some explanation of the meme, man, or a reference. CUDA home. Okay, got it. Ah, so that's the thing. It's complaining because I have CUDA 12.2, but we installed different version here. So we grab the output from this guy, and then we split, and then we find the release, and then we find the release and the major and the minor, and then we take the version of this one, 11.3 versus 12.2. If they are different, then we have to, okay. A minor version mismatch will not cause later errors. Huh. Okay, at least we know what's going on. So we have a couple of options. One option is try and install newer PyTorch. Okay, let's potentially try. Let's create a new environment, guys. Let's install Torch with 12.2. Because I don't want to mess up with my base CUDA setup. But what the heck? Maybe it even works. Let's try one weird thing. Comment out this whole thing and just see what happens. Let's just rerun it. This is complete YOLO. Complete YOLO. Okay, because let's find how people are coping with this. With Apex. Oh my god. That looks very relevant. Okay, let's see whether anything interesting here. Let's see. Can you share more details about the model encoding? Okay, let's try and install CUDA toolkit 11.6. Channel PyTorch. Okay guys, what I'm gonna do is create a new conda environment, conda create NLLB2. Python needs to be, if I recall correctly, 3.8. Let me just double check here. Conda activate NLLB. Python 3.9. Okay, that's 3.9. Is there any mention of Python? Why am I using 3.9? I think Python. Okay, they did not mention it here, so all good. Let's just use 3.9. Name NLLB2. Yes, install it. Conda activate NLLB2. Okay, let's go and do the following. Install PyTorch, Torch Vision, Torch Audio. From there, what do we see in there? Why not try 12.2? Again, CUDA 11.3. Torch text. Okay, so we might have to do something like this from PyTorch. Torch Vision, Torch Audio, CUDA Toolkit. Will this work? If it works, we might have a chance of, okay, well, not really. Let's try Conda Forge as well. Okay, not managing to find the actual version. What's up here? With CUDA 12. Okay. Got the following output. I would recommend to make sure no CUDA can be found. Torch. we just install the latest torch, what happens? Install PyTorch. Okay, apparently CUDA is not yet supported. 12.2 is not yet supported, which is the one I have on my system, which I'm not gonna touch with a stick. Can we compile for 12.2? Okay, this might be a bit harder than I thought. I don't want to break my Ubuntu again with CUDA kernels. PyTorch GitHub. Let me see whether there are any instructions. Building from source. Installation from source. Install. Okay, this might take a while to set up. Let me see whether anybody do that 12. Do you guys hear me, by the way? Trying to install Torch 2 with CUDA 11.8. CUDA 12. Let's just see the most recent issues. Is open. CUDA 12. Any question related to CUDA 12? Oh my god, so many issues. There's no people in the world can fix this. Okay. Let's see whether we can install Apex using not the system CUDA, but CUDA from Conda. That will be amazing. NVIDIA Apex Conda install. Get started with Apex. go to Reddit. Installing Apex for PyTorch. Why not? Installing Apex. Conda install Apex. If we just ran this, what's the chance of that ever working? Let me see. We can maybe install another conda. We can install another CUDA installation and try not mess up my Ubuntu. That would suck. That would really suck because there is a lot of files that I'm running locally that I did not submit anywhere. Reinstallation. Download the toolkit. Multiple installations. What happens in that case? Multiple CUDA installations Ubuntu. No, I have no idea what's gonna happen if I just run that command. I can't risk it. Okay, I'm gonna give up on the idea of running Apex for now. Let me just make a note. I can't build Apex. Can't we somehow force a usage of CUDA from the conda environment? Why does this have to work like this? Let's see, let's rerun this. F5. Distributed lamp. All good there. Then we extend. Wait, why not? Guys, why not just change the CUDA directory? That's it. Let's just change. Let's see where. Let me go to my conda activate LB. And let's see where it is. Where is it located? Let me find the CUDA from the conda environment. So if we go here, environments, NLLB, binary, CUDA lib CUDA. Okay, CUDA is here. So can't we just grab this? Okay, I think I have an idea. We might be able to hack this. This directory version remove and add this. Just defining some functions, that's all fine. Let's continue, let's get to here. Okay. So CUDA home. Why are we using this one? Why not? Let's see what's in that directory. Let's just go there. Oops. Like this. And open up the file explorer and see what else we have there. Okay. So we have a ton of things. There is the binary. There is the lib. There is the include. Okay. Let's try one hack. First, we're gonna uncomment this. And then we're gonna grab the CUDA home. Torch util CPP extension. Let's see how it's called. Torch util CPP extension. Always like this. Always like this. Always like this. And then there is also CPP extension. CUDA home. Let's put a breakpoint there. Same here. But otherwise it's always coming from, okay, one more. Okay, all of these are CPP extension home. Let's just change this such that it's pointing to, let me see where we have NVCC here. We actually don't. Ah, snap. Where do I have NVCC on my system? Let's find type file and then NVCC X or wait. Let's just find NVCC like this. Okay, there is in the bin directory. If I do root, permission denied, And there is a couple more, okay? Permission denied. CUDA 12.2. A ton of permission denied. And there is some CMake. Okay. Let's see with Miniconda. Okay, this is gonna be hopeless. We got stuck here. Trying to hack this and force it to use the CUDA library from my Conda environment. And then use NVCC from the original system CUDA. Could we do that? Could we just paste in here what would happen if we were to modify this such that this is using the right directory? Like this. And then we grab the CUDA home. And we just set it to something else. Torch utils home, it's gonna be equal to NLLB path. Like this. What would happen in that case? Let's see. Let's stop this. Let's rerun. So this environment does contain CUDA. So why can't we just reuse it? Why can't we just reuse it? Okay, actually, that's gonna fail again because the whole point is bare metal major. Let's just retrieve, let's just hard code something here such that we're retrieving (11.3). Rerun. this is the biggest hack ever. So okay, let's execute this. Let's continue. Let's continue. Let's go. Skip this, skip that. Enter here. Check the CUDA version. We get some raw output, but we don't care about that. Major, minor. Okay, so this is now 12. Even though we've set it to... Okay, just a second, we didn't modify this function. Let's give back 11, 3, and let's rerun. Rerun the code. F5. Okay, we're good there. Let's extend this. Let's extend it as well here. Let's go to here. Let's continue. X entropy. We extend it. We continue. Use atom. Let's continue. Let's go inside here. Get the bare metal major, it's 11. Run Apex. Let's continue here. Continue here. We can just keep on skipping these until here. And then let's see what happens. So we call setup. We call the setup. Okay, this failed. Well, let's try and rerun it here. So pip let's see what's the command that we need to run to install Apex. Again, the command is here, pip install. Why would this fail now? Let's see. Let's just navigate first to Apex. Copy the path. Let's go to Apex. Again, that's a prerequisite here. We go to Apex, we check out the particular commit, we've done that. And finally, we copy this. And we run it. And it's failing again. Because no such file or directory. Why not just, okay, I'm gonna do one super big hack. No, that's not gonna work. Oh my god. Let's get NVCC exe for 11.3. Ubuntu. Can we somehow just get the NVCC for 11.3? Okay. This is too big of a struggle to try and install Apex with the current system CUDA I have. And I don't want to risk breaking my system just to install Apex. Super, super painful. It's 2023 and NVIDIA still hasn't made it easier to run all of this. Crazy. Okay. I would really love to install it just to try it out. But if I go and reinstall my system CUDA or just add another installation, I might risk breaking something because these commands are completely black box. So it might override my driver or something. So I can't risk that really. So let's see. Okay, I'm gonna leave this as a later to do. Okay. Let me fix the download datasets functions. To understand so that we don't have to run the modification structure scripts. Let me ask in the Discord. Did anyone manage to install Apex? I have a mismatch between system CUDA 12.2 and CUDA from my env, which is 11.3 as per install instructions. I could do multiple CUDA installations on my system, but I might break my Ubuntu, and so I'm very reluctant. you Animesh, let me just reply to him. You won't be able to run this on Windows. Just go with direct Linux installation or potentially VSL2. Like this one. Okay. Let's go. Let's do a second pass over the whole pipeline. And then at the end we're gonna compute how many GPUs we need and the compute hours. Let's first start with fair_sec. And then let's go to download data. So examples, NLLB, download parallel corpora. We need to modify this. So that we don't need to have this script here, which is bothersome. Okay. Download. Let me just restart again this because linter is dead. New window, open up the fair_sec. Here we are. Please load it. Okay, nice. Individual public corpora for NLLB. Directory parse, grab the directory. If it doesn't exist, we create it. Okay, let's go here. Let's start with this data set. So our goal is to have all of these functions handle the download in such a way that they create a particular output structure. Otherwise, they all have their own perks. So let's start with this one. Let me change my launch JSON. Download primary data. And let's add number 3 here. And let's go to the download script. Let's go to TIL and handle this gracefully here. Each download function. Currently, we enforce that by running the modified dataset structure script. which is error prone. For start, some people will forget to run it. Okay, let's go. Let's close Apex, we don't need this. And let's go to parsec. Here we are. Download corpora, TIL. Okay. So the output is going to be here. And then we grab, using gsutil, we run it. And then we map the 3-letter ISO code for NLLB lengths. Let's see whether we have, let's just make this nicer. Let's go to here. We already have some of those. Let's see whether all of these are there. AZ, not in there. BA, not in there. CB, English it is. KK, KY, Russian, TK, TR, TT, UG, UZ. Let's just do this. Just expand the global dictionary, assuming that they have valid codes there. If not, then screw it. Then we'll have to keep it inside there. Let's just double check this makes sense. Oops. Let's open up the codes here. And let's double check that these codes make sense. AZ, Azerbaijani, BA is okay. Apparently, I already see a discrepancy. This one maps to Buck. Okay, that's good. That's actually good. Then we have CV, CHV. Okay, English good. KK, KAZ, KY. KY maps to KIR. That's good. Russian good. TK maps to TUK. That's good as well. TR maps to TUR. That's good. TT maps to TAT. That's good. UG maps to UIG, and UZ maps to, that's all good. Okay, so we can remove this. We don't need this. We can just grab and import from lang code mappings. Import what? We import ISO 631.233, and let's go to download till. Download till, and we can just remove this and instead use this. Clean this up a bit. Okay. I actually want to raise the error if that happens. Okay. Then we go there and we do what? We grab the source and the target. We get the 3-letter code. We should not hit this. And then inside of the pair directory, we basically do some renaming. To the 3-letter codes. Okay, makes sense. Guys, let's rerun this. Let's create this. This is gonna make our lives so much easier. Put the breakpoint here. Run the code. It's gonna take a while to just, whoops, wrong settings file. Okay, download data. Let's go. Whoops. Here we are. Exist. What's the flag we are using always? Okay, make directories exist. Okay, this is the right one. Okay, run it. Run it again. Something is failing here. Okay, all good. So download data here, saving the data, running. As you can see, it's downloading a ton of data, and some of those are using 3-letter codes, some of them are using 2-letter codes. That's the takeaway there. I'm going to immediately map those to BCP47. Immediately map those to BCP47. Let's go up here. I should have done this immediately. Map to 3-letter code, and then if this happens, and assert that length of this is 3. Assert that length of target is 3, and source in keys here. And target in keys here. Okay. Looking good. Let's see what happens. It's a bit slower to download. So we split. Again, I don't want to have secret exceptions. I want to crash the job if this does not work. No silent failures. Okay, map to 3, and then no, otherwise we just map to, okay, keep it like that, and then destination source is PCP, oops, PCP like this, source, and same here. Target. Now they are in the right format. And now this should work. So we go through the directories, we grab the source and the target language code. We map those always to BCP47. Then we construct the directory path, and we grab the original file and instead replace it with TIL, and then we do it like this. This makes sense. So this is going to rename the files into a correct suffix. Let's create some structure here a bit. Let's always have corpus name as the prefix. Destination source to destination target. And we rename directory. No need to print that. Let's do an F string here. This, no need to do that. Looking good. Let me just add a bunch of breakpoints because I modified the code, so I'm not sure when this is going to stop. It has to stop somewhere. Okay. So now this is in the right structure. I want to do one more thing. Corpus name is gonna be till, and then let's put it here. Let's put it here. The URL. And in particular here. And then language BCP 47 code 1 to code 2, and then underneath it we have till BCP code 1 till BCP code 2, and then same thing here. Exactly. And that's something we're going to enforce for each of our corpuses, corpora. Okay, looking good. Almost there. Couple more gigabytes and $22.4 gigabytes saved. Now let's stop. Let's comment out this particular line. We will not be running again. Let's just save this and let's rerun. Okay. So here it is. Here's the data. Let's now iterate through the data. Grab the source and target, map to 3-letter code, map to actual. Okay, just a second. A couple of things we have to do here is grab 0, because we have a list in the mapping. And we also want to make sure that we are not hitting any ambiguous codes. If ambiguous code, we have to resolve that. If an ambiguous code is in there, we have to solve that. Okay. And those ambiguous codes are three-letter codes. Okay. So if destination source in ambiguous codes, then we please manually decide which script is being used. Okay, let me import that variable. And then let's do the same thing here. Let's stop it. And let's rerun it. So after this, I'll have much more confidence in our data. We can clean this up a bit. If length of this is 2, okay, something like this. Just to make this a bit cleaner. If you're in the ambiguous code group, then we raise exception. Otherwise, we map to BCP. Same here. If the length is 2, then we map, otherwise we just do that, and then finally destination target. Looking good, guys. This is now looking good. Let's rerun everything. Okay, target. Okay, we immediately hit some issue. Why would it be T? TT? Oh. That was a mistake. We grabbed 0 only for the BCP47, not here. Okay. That was an easy one. Map it to BCP47. Map it to BCP47. Rename the file. Let's find what's the file. TILTTKK. TTKK is here. So let's rename it. Here it is. And here we also rename as well. And finally, we rename the dictionary, sorry, the directory. So now we have the right format as expected. Let me actually just run this and see whether we hit any issues. Okay, we do. CHV does not have any mapping. What's up with CHV? Let's see, what did I write down about CHV? Not mention the papers, filtering it out. Okay, so that means for some of these, do we want to delete those, or do we want to let me think for a second. Download Feral Corporate. Maybe we can delete those. Maybe we can remove those directories immediately. If we are certain that these should not be used, then we can just delete it immediately. Okay, so let me open up the notes. CLR, not mention the paper. KUM, not mention the paper. SAH all the way to CGS, and then CHB, and then KRC, not mentioned, only as a part of Flores 200. Wait, let's just double check KRC. KRC only mentioned here, and we don't report anything, so we can completely ignore that language. Then there is the Tigray ER. We'll think about it a bit later, but AAR is AFAR not supported, NV also not supported, VEN also not supported, UUM not mentioned, can't find the ISA code. Filtering out. GAG. Not supported. So let's see how many of these were not mentioned. So in total, we should filter out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. and 4 there, so it's 15. Let's see whether we have 15 here. 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, plus this one. 1, 2, 3, 4, 8, and 7, 15. So that's the same group. We just add the Tigray. Do we have anyone from the language champions who speaks Tigray? Let's see. Ethiopian. Nobody speaks Ethiopian. Tig. If you know anyone who speaks Ethiopian, let's just post it to the general channel. Okay. So we can safely filter out everything that's in this list. So to do that, let's go here. Let's go here. Let's import the unsupported language codes. Let's import that as well. And let us basically do the following. If exactly. No, we're gonna remove. We're gonna do the OS remove this pair directory. Language is unsupported, deleting the directory. Deleting this piece of data. Okay. And we're gonna do the same thing for here. So if it's in the unsupported languages, then this is unsupported, and we remove this particular data piece. Okay, guys, let's rerun. So this is unsupported, so we delete it. Let's see how that happens. Whoops. Well, we can't. Wait a second. We have to use shutil, I think, and then remove tree. Exactly. Like this. Again, rerun. Let's remove it. Nice. And then, well, after we do that, then we have to just say continue to the next one. Okay, if we hit ambiguous code, we raise exception to resolve the ambiguity. Otherwise, if we hit the unsupported one, we remove that data set and we continue. Let's continue. Let's just remove this and let's hit F5 and see what happens. Okay, we've hit some issue. Why? Because it's already CRH Latin. Okay, interesting. Let's grab that regex pattern. So BCP 47 regex is in here. Let's import it from here instead. And let's put it there. Let's go to the language code mappings. Let's import the BCP regex here. And let's import the regex package. Let's go back. Let's see how it's used here. Assert its matching. Go to download. Okay. So if it's length 2, we map, otherwise we do this. Then we try to do this. If there is an exception, we have to assert that it's in the right format already. And we cannot recover. Okay, let's do the same thing here. We try and map into BCP 47. If that's failing, then we make an assertion that it is in that format already. So again, a bit messy. If it's a length 2 code, we convert it into length 3. Otherwise, we just map it here. Okay, this might cause us issues because here we are assuming that it's letter 3 code already. Because here, this is letter 3. Ambiguous and unsupported are both 6393 code. So that means we expect this to be in that format already. So instead, let's do the following. If this is true, then we split and grab the 0th one. So this has to be, basically we're trying to force it to be in 3-letter code. And then after that, we won't need to do this. And let's do the same logic here. So after we map, we want to make sure that this is, if it's matching BCP 47 already, we are going to split and grab just a 3-letter code. And then if you're ambiguous, we raise exception. If you're unsupported, we remove and continue. Otherwise, we map to BCP 47 and continue. So this looks good. Okay, let's rerun. Okay, additional error, this should be underscore. This should just be an underscore. And now this should work. So at best we'll hit, please manually specify some of these. No such file or directory. Wait, what's going on? Guys, for those of you who just joined, I'm taking care of the download functions such that the responsibility for the right structure is on their side. And I'm currently handling the TIL dataset. So this might take a while today to just sort this out, but after this we have guarantees that our primary dataset is in the correct shape. Just very important data work today. In a couple of days we'll be in the position to start bigger runs and request more compute. So why did this fail? CRH Latin to LUG Latin. CRH Latin to LUG Latin. Let's find that. Okay. We've already done that. When did we modify this? 2:44 p.m. Okay, just a second. Try and rename this. If it fails, then make sure that these are already in the right format. If it fails, then we grab the files from here and make sure that file 0 equals, just let's assert that file 0 equals this, and file 1 equals this. Okay, this looks good. Now there could be some ambiguity, so I have to take care of that. Let me just think for a second. So if destination source is in files 0, then we assert that it's equal to this. Otherwise, we assert that equals corpus name. Okay, this looks good now. So again, if destination source is in the file, that means we need to check that this file already has this shape. Otherwise, we need to make sure that it has the other shape, the target. And same goes here. If destination target is in the file 1, then we do this. Otherwise, we make sure it has a source. Okay. Let's rerun. And that's it. We're done, guys. We've deleted a ton of data from TIL because it's not supported. But we end up with a clean, completely clean data set once it's downloaded. And that's it. Looking amazing. So we won't have, so each of the download files, each of the download functions will basically be responsible of taking care of this structure. Okay. Now we can re-enable this, and I can push out this change. This is Apex. So delete that. Close it. I don't know what I'm rambling at this point. So we are in NLLB. Git status. Let's commit this. If you could make a consolidated video at the end, that would be really great. That's gonna be hard. Too much content, too little time at this point of time. But maybe somebody can take out some clips or something. Okay, let's see what is the change here. Modify data structure. What did I change in that particular file? Modify data structure. Let's see. Okay, I moved this to here. That makes sense. Let's see what we changed in the mappings file. We added a couple more 2-letter to 3-letter code mappings and the regex. That looks good as well. And finally, in the download script, we have a ton of changes. Some changes here. We don't need this condition here. Some typo here. And then completely new logic for the TIL dataset. Okay, so that's it. New logic for TIL. Typo, all of this makes sense. Let's basically now submit this. Git add download parallel corpora. Git add the mappings. And git add the structure. Git commit, basically saying refactor TIL so as to support the new dataset structure. Push to origin. Okay, awesome. Okay, guys. My battery might die very soon. We are at the end of this stream either way. Next step, I'm gonna handle the rest of these data sets, and let me go grab a lunch break for now, and then later we can continue. We're going to refactor all of these download scripts such that we are certain that our data is in the right structure and clean. And that's it for now. Let's continue in 30 minutes roughly. So 3:50 p.m. CET. Catch you soon, guys. And Shubhang, thanks for the suggestion. It's just currently I'm streaming 10-11 hours working on these projects. It's gonna be hard for me to additionally edit stuff unless somebody's doing that for me, because I literally don't have the time to do that. By definition of streaming 11 hours. Cool. Catch you later, guys, in 30 minutes. Let me just stop the stream. Bye-bye. Let me see, where is my... I don't even see the end stream option anymore. Just a second.